So in this section we're actually sketching rays, and I don't even think it's mentioned in the book, just having a quick look through the book, but when you're dealing with angles, and I'll just write this down so you can see it, and you're graphing them, these are called rays, like R-A-Y-Z. And the reason for that is you can think about them as like rays in the sun emanate from the sun, so they're lines coming out from, if you draw the sun, where's my pen? If you were to draw the sun, well, you draw the rays coming out. Well, rays are just lines that you're going to draw on a graph. So that's why they're called rays. So if we look at the first one, we've got arg-z. Now, all of these actually have arg, so it's a good idea to remember what arg is. Remember that arg-z actually is defined so that the angle is in between two endpoints, not including negative pi, but including pi. So as a graph, you're really allowed to start here and go all the way to pi, but when you go around this way, you're actually going to stop short of negative pi. So there's a sort of region there that you can't cross as a line. So you can be in any of those regions there, but you can't cross over. So that's what arg is. And you can see here pi on 3 is within the arg that we need. It's here. That's correct. Negative pi on 3 is there. That's correct as well. And pi on 3. So they're already set up in the correct format. So let's look at A. We've got arg-z equals pi on 3. This is saying show the angle or the complex number where the angle would be pi on 3. Now, the way you can think about this, and I'm just going to graph this here, is imagine that you've got on your real and your imaginary a number, let's say pi on 3 is, I'm just going to use a line here, pi on 3 we'll say is here, okay? Now if we think about this, what this means is you could have a complex number that sits here, and that has an angle of pi on 3. You could have one that sits here, you could have one here, here, here. We're not interested, admittedly you could think about things on this side, but that would be for tan. So there are only the things here, all along this. So if you can imagine filling this entire line with points, what you would have is this line here, which is called the ray. And that's the ray where any complex number that has this angle, pi on 3, would sit. It's conceivable that you could have any distance from the origin, because all complex numbers have different distances from the origin, but all the complex numbers that have this angle would sit on this line. So that's why we just draw a straight line through that angle, and that's all we have to do for that graph. The arg of z, the complex numbers that have arg of z pi on 3 would be all the ones that sit here. The next one, we've got arg of z plus 3 equals negative pi on 3. There's two things going on here, the angle of the complex number, and also this is a kind of shift of the origin, if you think of it that way. So rather than starting the measurement from here, from the origin where we normally start, we're now going to shift the origin, and here you can see the origin is going to shift 3 to the left. Okay. The reason it's to the left and not down, I drew down first, which is really bad. Down would have an I. Remember that the imaginary is up and down. The real, and you can see here that this is a real number, real is left and right, and because it's a positive it will be that way, negative. So the shift of the origin is that way to negative 3. So if we graph this one now, what you're going to be doing, again we'll get some axes, might do these ones sort of nice straight lines. Oops. Okay, is we're going to go 1, 2, 3 across. So we're starting over here now. This is our new origin, and the angle that we have is negative pi on 3. Negative pi on 3, remember, would be like this sort of direction here, and so rather than drawing it here from the origin, we're actually going to, and I'll draw it here, we're actually going to pick that up and put it where our new starting point is, at pi on 3. And you want to show people that that angle is pi on 3 as well, just by labelling that pi on 3 there. So that angle, that's pi on 3, and we've translated or shifted the origin over. So arg of z minus 3 is negative pi on 3, down that way. The last one, see if you can try this one without me. So you can pause the video and have a go at this one. You've got arg of z is greater than or equal to pi on 3. Now we know the first thing, let's just get our graph, our axes, and we should be making sure as well that we label our axes. So the real and the imaginary. Alright, so now we've got arg of z is less than or equal to pi on 3. Let's have a look. Pi on 3, there's no translation here, so we're going to be starting at the origin. Pi on 3, remember, is an angle, a ray going sort of this direction, 60 degrees, so a little bit more than 45 degrees. Now we have an equal sign here, it's a less than or equals to, so this will be a solid line. Okay. Now we want all the angles that are less than or equal to pi on 3. Now angles that are less than would be in this direction, because any angles this way would be greater than. So we don't need the ones on this side, we only need the ones on this side. And to show that, we literally shade this region in. Now we also can include these angles here, because these are actually less than pi on 3 as well. So we're going to shade those in. And we're going to shade to here, but the important thing to do here is to actually put a dotted line, because you want to show at pi that you can't include pi. So show that by using a dotted line. So a solid line here because you can include this section of the graph, but all the angles that are less than pi on 3 and equal to pi on 3, you can't include pi. And it's a nice idea to just have a little key that says that this is the region required, because that really shows that you know what you're doing, then you're showing off that that's what you've shaded in. So that's the idea with graphs and with graphs with rays, looking at the angle, and when you're dealing with something that's an arg type graph, you're going to be drawing a ray. The question is just, where is the ray going to be? Is it translated in its starting point? And are you going to be shading a region around that ray?